All right, so what's up?
21 and 5.
All right, guys, so this is section 5.5, page 413. Oh, yeah, it's my favorites.
Yeah.
Question is or the chapter is?
Yeah. Pretty much. Now, very often, the inside function is really easy to tell. So a more general way to say that U substitution is all about letting U be the inside function is to actually say U is the function whose derivative is in there. Right? So I used to say it's sort of like ragu, and now that reference is kind of getting really, really old, so it's in there. So I wouldn't let U equal x, because that's not going to take me anywhere. Because its derivative would be du, and it doesn't do anything for this. You guys kind of with me? Mm-hmm. So, but thankfully, whose derivative is in there, what function's in there, whose derivative is also in there?
1 over x.
Ln x, its derivative is 1 over x. So if I let u equal ln x, du is
1 over x.
Cool. So I've got this covered. That will be du. And this will become u squared. And that's really nice. Is that cool? Because now, of course, when you integrate that, you get
U cubed over 3 plus c.
and then you just put back in the ln.
Yeah.
You're done.
Fantastic.
It's almost too easy. You're like, that can't be right. It's totally right. How do you always check yourself?
You take the derivative.
Yeah, take the derivative. Get out of there. So the derivative of c goes away. The 3 would come down. We cancel with that 3. Ln x squared times the derivative of the inside 1 over x, ln x squared over x. Perfect. It works. So if you have any time at all, when you're doing a test, at the end, you just go back in and just take the derivative of everything you've integrated. Just make sure it becomes this. You're going to undo it to make sure that it works.
Can you please do 3A on the home or the practice test?
Did you have a question about this here, or just another?
Oh no, it's another one.
Okay, so which one?
3A. I think it's quite similar to what you just did, but the answer on whole mouthful is pretty complicated, so I just want to see the.
Yeah, there's no real shortcut. You mean this one?
Yeah.
There's absolutely. Get in there. There. All right. 3 is my worst number. There's no real shortcut to this. You have to just cube this thing out. So if you remember Pascal's triangle, it's relatively quick to do that. If you try to do a u substitution like u equal x minus 3 and then x equals u plus 3, you're making the bottom become 2 terms, which can only make things worse 99% of the time. So that's not the way to go. You just have to FOIL this out and then break it up.
Okay.
Yeah, so it is going to have pieces to it. I don't know what.
Could be worse. That sounds like that.
No,
There was like a log in there or something.
there will be. You can imagine, because you'll have a constant term over x.
Okay.
So it's going to come out a log when you integrate.
Can I do 33, please?
And Ivan, you had a question?
I was going to ask you 18 on the same section that we do before.
All right. And you wanted
33.
33. And so, okay, so 18, the sine one?
Yeah. No, on 5.5.
Yeah, the sine one. 18? Sine root x over root x.
I think I may have run the wrong one though.
Which one did you do?
A plus bx squared.
Oh, you did. Ooh, okay, we'll do that one, because that looks gross. That's number 19. I like the way you think. The one I assigned was too easy. So you said, screw that, Jeff.
Get extra credit for that.
No. That's funny. I made a mistake. Can I get extra credit? That's awesome. What was it? Bx squared? Bx cubed. That makes sense. Alright, this looks disgusting, but it's such a giveaway. I mean, which function has its derivative in there minus a constant? Because constants you can make work most of the time.
3x plus bx cubed has the derivative.
Yeah, the derivative of this would be 3a plus
dx, right?
3bx squared. So it's just off by a factor of 3. If there was a 2 there, I'd be screwed. I couldn't do u substitution. It wouldn't work, believe it or not. But there isn't, so thank God. So if I let u equal...
The bottom function.
Yeah, without the minus the root. Because its derivative, the derivative of the inside dude is sitting right there next to the dx. That's perfect. That's exactly what I want. Minus, of course, like I said earlier, derivative of this would be 3a plus 3bx squared. So I need to force a 3. So how do I do that?
Put 1/3 on that side.
Yeah, if I put a 1/3, it balances me putting a 3 there and there. So all this is du. I mean, isn't that satisfying? Isn't that you're consolidating all this crap? You're actually consolidating the derivative of a function. You're making the derivative of a function just derivative of a function, du. That's what that really means.
Wasn't there a half that needs to cancel as well?
Where am I at?
Wasn't there a half that needs to cancel because you assume that with the square root you get a 2 on the bottom that would need to go away. That would need to go away eventually.
Well, now I'm going to worry about it in the next step.
Okay.
So now I've got 1/3 integral 1 du over square root of u. So I can rewrite that as 1/3 u to the good negative 1/2, and then I integrate that blah blah blah. So that's where the power rule comes into play. Yeah. Is that cool? I like that Celtics sticker. You're trying to get points with me, it's going to work. My poor Celtics. Been scattered to the wind. All right. Is that okay?
Yeah.
You guys see how this kind of works? Very often that it'll just kind of scream at you, this is inside of something, and its derivatives, you can kind of start to see its derivative is sort of there. Minus the constant. Well, the constant you can always make work. So who cares about that, right? You just do this balancing act there, right? Maybe I can't gauge you guys at all. And the rest of it, hopefully, it's not that bad. How do you integrate this?
Drop it minus 1.
2
Add
u
one.
to the 1/2.
U to the 1/2.
2 over 1.
Good, times 2. All right, times the reciprocal of that.
Plus C.
Let's see. I get 2/3. U was
That's not.
3a plus bx cubed.
That's tough.
3ax plus bx cubed. It's 1/2 plus c. Done. And you can check it by taking the derivative. And derivatives are almost always quick. Right? Derivatives, you can do a derivative of almost anything. You can start to see how integrals, not so much. And we're used to the opposite function being harder. Okay? It's a very strange vibe in here. It's almost over, but I can't be happy yet. Right. That's what I'm picking up on. Okay. Anything else from?
Can we do 33?
Oh yeah, 33. That looks freaky. Let's see.
Same section?
Yep. I guess we'll see. This here? Yep, good. So, I mean, one thought would be to try to simplify this. Maybe it becomes a trig function whose integral I know. But if you try to simplify this, you'll get like 1 over sine, cosine over sine. So I get cosecant, cotangent. I don't know if you guys know. Do you remember the integral for that?
That's
Cosecant.
Negative cosecant, right? Secant derivative is secant tangent. Cosecant's derivative is negative cosecant cotangent, right? So that's not the way they wanted you to do it, but screw it.
how do they want you to do
They
it?
want you to use substitution. It's in that section, right?
Yeah.
But this is relatively, and this is negative cosecant. Put a C there, Jeff. Dun, 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 dun.
Like,
Let's see if we get the same thing. If we do U sub, how would you do U sub on this?
well, they could both almost be derivatives of each other, right?
Why would I not want to let U equal cosine?
Oh, because the sign squared?
Well,
Because
because
of the
derivative
Sin
cosine
x
is negative
to
sine.
you.
Because the sine x is on the,
Bottom.
and it can't go with the dx then, can it? Do you see that? You start to think, what am I free to move over next to the dx so it will equal du? So you got to be careful about that. And you start to, that's beautiful that you brought that up. I love it. Because that's, in general, you got to be really careful about what you let u equal. If there's two ways to do it, there really isn't. There's only one. The cosine is free to go with the dx. So you want to let u equal sine, and not sine squared.
Just sine.
That would so desperately suck. Right? You want u to equal sine.
How's that to be squared?
Yeah, exactly. So it'll be u squared at the bottom. So you start to, good. This is exactly what it's really difficult to tailor a lesson to capture. You have to kind of see it as you go. What are you allowed to do? What's the freedom? You have almost too much freedom.
Okay, so then it would be like 1 u squared times du.
1 over u squared du. I love it. Right?
You can bring that up to the
So you have a lot of freedom as to what to try to let u equal. But then you start to try to do it and you realize that's not going to get me anywhere. But at least now you know you don't have to let u equal sine squared. Because this is sine squared. I can let u equal sine.
Gotcha.
And like you said, it'd be 1 over u squared. So u equals sine, du equals
Cosine.
cosine.
X to use.
So I get integral cosine x dx is du. And sine squared is now u squared. You'll see it like this,
Isn't that negative?
or you'll see it like that.
Then when you take the integral, though, you end up with just 1 over u?
Let me go back for a second. Derivative of sine is cosine.
Oh, I was gonna, okay.
Yeah. Say it
So
again.
the integral of 1 over u squared just be 1 over u?
Almost. Because this is integral of u negative 2, right? So it'll be u negative 1 over negative 1.
Okay.
There's got to be a negative there
Right,
to kill the
because- yeah,
negative
yeah,
that's
yeah.
coming.
So negative 1.
And then you just bring back in what u was.
Oh,
Right.
okay.
So it'll be negative. Let's see. We better get the same thing we just got over there. Now, see, negative powers I can't put there for the trig because that would look like as if it's
Inverse.
arc sine, inverse sine, yeah. But what is, of course, reciprocal of
Sine
sine?
over sine is
Cosecant.
Cosecant. So we get the same answer. Just this way was a hell of a lot better. So the first thing I try with trig functions is just to rewrite them, just to use trig identities or simplify them, because maybe it'll become something that I can just integrate directly. Right? Why go through this if I don't need to?
Looks like they required almost the same amount of work, though, right?
That's just numbers.
I don't know. Trying to figure out which piece to let u equal. I mean, that's good practice. So on that side, I'd like you to do it this way. It's practice. But if I just ask you to do it, I hope to God you do it this way because it's quicker.
Okay.
Yeah. Yeah.
Can you please take a look at number 4 on the practice test? I didn't understand exactly what it was asking.
Me either. Oh yeah, report. So I give you a rate of savings,
Yeah.
and the rate of savings is continuous function. It's for all values of t. So when I ask you to find a formula for the total savings in the first t years, so it's from how many years up to how many years? From 0 to t. So I want to know, and it's kind of my mistake, sort of, but you got to be careful when you do this. So if I want to go from 0 to t, so I want to integrate this rate. I can't use t here. I got to use a dummy variable for a second, so I just put x in this place. Because t means time. It doesn't matter what variable I use for the function. I can't use the same variable I've got there in there. Those can't go. So, but if I add up continuously the rate of money that I'm collecting, then I'm going to end up with the total amount of money I'm collecting. So it's like multiplying the amount per year times the number of years. Of course I'm going to end up with the amount. Right? So integrals undo rates and bring them back to just amounts. You with me? Kind of makes sense because derivatives are all about amount per time or amount per something. Integrals takes it back to just pure amounts. It undoes the rate part of it.
So assuming we were given a year for t, we would just use the fundamental theorem of calculus part 2 and just to kind of find what the maximum was during that time or something?
Sure. And I could say in the first 3 years, how much money would you save?
It would be the...
And then you use 0 to 3 this. But what we're doing right now is actually just finding this, if you realize, well, sort of, when you integrate this, how does that work? Now this is a little bit freaky, but when I integrate e to the ax, we can kind of make a rule for this. When I integrate this, now what's going to happen when I take a derivative? A comes out here. So what do I have to have there so I can kill it? Yeah. So that's a general rule for e to a linear function of x. It's just the same thing divided by the slope.
So if you take the integral, it does the same thing as the derivative in this?
No. If I were to differentiate, an a would come down. Do I have an a here?
No.
How do I kill it then? Divide by.
So then the integral only just divides by a.
Doesn't matter. Yes, and it's the same thing. If I try to integrate this, that comes from x to the 4th. But if I differentiate this, and does a 4 show up?
Yes.
But I don't want a 4 to be there, so I kill it.
Okay.
Right. So that idea almost seems non-mathematical. It's like but that's exactly why it's there. Really, that's one way to look at it. That works perfectly. Same thing here. Whatever's going to show up here number-wise, I can kill. Now, people take that too far and they say, okay, e to the ax squared. If I want to integrate that, then what's going to come down here is 2ax. Let me just divide by 2a. No, you can't do shit with your variable, right? It's constants you could do all day. Divide by them and stuff. Constants don't matter. Your variable defines what type of function is. You can't just throw that in there to balance it out. You guys at all understand what I'm trying to say there? You got to be really careful about extending that reasoning too far.
Then what do you do?
Huh?
What do you do?
On this problem, you're completely screwed. Because this is, you actually will learn how to integrate that in 280. It requires a series answer. There's no closed form. It's called a transcendental, not just a transcendental function. What is it called? Screw it. Come on. It's just bad news. And real quick, I'm not going to let that go for a second. What's missing from in here for me to be able to do this integral? I want to do u sub. But what's missing?
1/3.
2x.
2x.
You can't divide by that.
No, you can't.
Oh, because it's 2x.
You can't say u is x squared, so du is 2x dx, and go, I need a 2x, yay. So that's kind of like what I was talking about. You're not allowed to play with functions like that. You can't have an x on the outside and inside and balance them out. No, you can't do that. Because the integral is affecting the x. It can't suddenly pop out and then go all over the place. Then everything's easy. Integral of tangent of square root of x. Let me just take this whole thing out, and that's easy. No. Right? Calculus stuff. Why do people make such a big deal out of it?
So then in that particular case, would you have just, is that math?
You like I said, you're screwed in that one specifically.
You have e to the x squared or anything. Where
Yeah, e to the x squared is not integrable. I gotta be careful how I say this. It doesn't have a closed form answer.
Okay.
You answer it with an infinite sum of functional pieces.
Okay.
I'll leave that for Calc 2. I'm hoping one person here goes, that sounds interesting, instead of, no, thank you. Anyway, so all that crap, what can I do? How do I take the integral of that?
Well, it's 1/10, so wouldn't it be 11/10 would be the...
Careful, no, don't.
Put that at the bottom. Good.
Right, that's what we just figured out. Integral of e to the ax equals e to the ax over a.
Yes.
Plus, this is definite, so who cares? And of course, 200 divided by 0.1 is
2.
No, 200/1 is
2,000. And then you just plug in t. You plug in 0. What do you get when you plug in 0?
1.
No.
2,000.
2,000. Okay. So at time 0, how much money have you saved
Not
Nothing,
much.
which makes sense. I mean, you just installed the damn thing. You haven't saved any money yet. You kind of with me? Okay, maybe. And now part B is easy to ask, to answer. Yeah, set that equal to 1500 and solve for t. Right? Pre-calc stuff.
Section 6.2, number 34.
Oh, okay, cool. So this one, they allow you to use your calculator. So this one says, you said 34?
Yeah.
Yep. 34, 6.2. This one says, take the region defined by y equals x squared and x squared plus y squared equals 1 and y greater equals 0. And go around the x-axis, go around the y-axis. So we'll do part A first. Oh boy. So this part here, what does this part here mean?
Above y-axis.
No, all the numbers.
Yeah, so when you say above, y equals 0 is which axis?
X-axis.
X-axis. So above the x-axis. That's what this says. So I know I'm operating above the x-axis, which is really nice because this bad boy is a
Circle.
circle. So now I've got the top part of it, so that's makes that a little easier, right? So I have y equals x squared. Let's make this a little bit defined here. So here's y equals x squared. And then x squared plus y squared equals 1. So that's a circle, and we know it's the top part of the circle of radius 1. So that's easy enough. So now, the region is this here then. You see how that came together really nice?
Yes.
So the region is this region here. So what's really important then? I mean,
You want the integral of the
Intersection of the two points.
x squared between 1 and negative 1.
yeah, so I'm going around the x-axis. So it's going to be integral what?
Yes.
dx. I love it. So anything parallel to the x-axis for washers and discs. And it's got to be what this is, because this is not shells yet. This is the next section.
Maybe we're just messing with you. It's a shell.
Could be.
to throw you
They
off.
do that. Well, you guys kind of with me so far? I mean, you have to do this rough sketch. You have to.
Your circle is your top function, you know that?
Okay, good, perfect. So the circle part is your top function.
X squared plus y squared.
And this is y equals x squared. And everything's dx, so everything has to be in terms of x. So what can I do here?
Y is equal to the square root of 1 minus x squared.
I know it's plus because of what we just said. So on the top part. You guys kind of still with me? So to see how that, what's desperately important here is not the specific functions and all that kind of shit. What did I do first? I sketched it first. Then I came back and said, okay, x-axis, dx, everything's got to be in terms of x. That tells me to go solve for x where it isn't already solved. Do you see how everything kind of flows into each other? So it's not like, when do I know when it's x? Well, look what you just wrote, dx, because it's around the x-axis. Because it's a washer or a disk. You're going to love it when it's a shell, which is completely the opposite. All right. So now what's next? What do I need to know for, is this going to be a washer or a disk? Like it really matters, but
Washer.
yeah, why is it a washer?
There's a difference between the two.
Good. There's space in between the thing I'm rotating and what I'm rotating it around. So there's going to be empty space inside. That's the inner radius, outer radius deal. So that's the next important part is, what's in general, what goes in there? Why am I giving it a
Radius.
Yeah. So the area of the whole thing minus the area of the part in the middle.
Why did you throw the pi in there? the pi times that.
Because remember, when we were, so don't forget what we're doing. We're going to rotate this thing around.
So it's because of the rotation, that's what it is.
And yeah, so all right, and I really want, so I'm going to get this like, this should be interesting. So I'm going to have this, and then this is going to be rotated around, right? So it's this really weird shape with this, it's connected to the center, yeah, there's a hole in the middle, it's neat. I like it. What was my whole point? Oh, so at some x value, I'm going to have this inner part and this out of that. For me, that's not bad. So if you look at it this way, you got that. So I need so it's all circles. Is really what it's based. Trust me, it is. Right? So area of a circle minus the area of the other circle. Right? The area of this big circle minus the area of the small circle, because that's a hole in it.
Then you have the area that you want.
So it's almost, again, the idea, you get so stuck in the procedure of it, you forget that it's built on almost too easy of an idea. I'm just adding up a bunch of freaking circles. Now in this case, I'm subtracting some out because I got a middle that's hollow. But the idea is almost too simple. That's why it's just this pi r squared, basically, right? So now what I got to figure out is what's our outer, what's our inner.
Outer is the top function, which is the square root of...
Good. So that's why it was good to know what the top function was. So our outer equals this. So our inner must be x squared. You guys with me? So you always start drawing from what you're rotating around out to the outside function. That's our outer. That's crazy. And then to the inside function, that's our inner. Right, so if I was rotating around x equal negative, y equal -2, then it would have been 2 plus that, right? That's how far away it would have been for the
Since
radius.
they switch, don't you add them at 1 then when they...
They don't switch because we stop where they meet.
Oh, we're stopping where they meet, okay.
So that's the part I haven't heard anybody say anything about yet, but I was waiting because when we get to the point where we got to figure out what goes here and here, that's when I was hoping somebody would suggest what the hell to do.
No, you're
Right?
right.
So what goes inside RO squared? That's nice.
It's just 1 minus x squared
Love it.
minus x to the 4th.
Beautiful. So that's going to be an easy integral. But the problem is,
We just said we only do between -1 and 1,
We have
right?
to set the...
is it?
No, we have to set them equal to each other.
That region doesn't go from -1 to 1. That region goes from something to something.
Set them equal to each other.
Yeah, it's easier than you think. This first one says y equals x squared. And the second one says x squared plus y squared equals 1. So what's x squared?
1 minus y squared.
Yeah.
X squared is y.
Yeah.
So
So y.
So to figure out these limits, I want to know where these meet. And if they're supposed to meet, they're supposed to both be true at the same time. So if I know that y is x squared, I can replace x squared with y.
we have y plus y squared.
So to figure out these positions here, are you guys semi with me here?
Yes.
I mean, the limits come from, very often they'll come from where these two things overlap. They might come from the interval they give you. Right? They'll tell you from this to this, integrate. But here they come from where they overlap, because I'm only going to rotate the inner part. So it matters where they overlap.
Lovely.
By quadratic formula we can find.
Traffic.
Quadratic.
Quadratic, exactly. So y squared plus y minus 1 equals 0. That won't factor, you got to use quadratic. I love it. Now the limits in this case are the gross part. The integral is actually easy.
Y will be -1 plus or minus square root of 5 over 2.
Sure. I'm not back. So -1 plus or minus square root of
5.
1 minus 4a, see, I agree. Good. Divided by 2. So that's your limits. It's going to be from -1 minus root 5. Oops. -1 plus root 5.
Can we take it from 0 to positive?
Yes, so you could use symmetry if you wanted to and make it 0 up to this and then just double whatever you get. Now you got to be really careful, especially with volumes. Sometimes the symmetry is broken based on the axis they use. In this case, it's symmetric to the y-axis, so that'll work most of the time. But in general, you got to be real careful about using symmetry to break it up. But in this case, it'll work. Or you don't worry about that. You just plug in these gross values and
Plug in chart.
Yep. Right. So you got to first integrate, and then you can plug those in. So your limit values obviously don't have to be pretty, right? So what were the steps? First thing you do really is figure out is dx or dy. Then you draw a rough sketch and figure out who's our outer, who's our inner, based on whatever variable you put there.
So that was draw first and then figure out.
I know. I was
We picked it because it was about the x-axis, right? That's where we picked x.
Yeah, the important part was this dx, because of the fact that it was the x-axis.
Okay,
now part B says, remember that's just part A.
Just switched around in the y-axis just to mess with you.
We've already done a lot of work that's going to help us with part B, but part B says, take that same area, take this area here and rotate it around.
Why?
Don't say 45 degrees.
Why?
It's a very strange question. Yeah, I don't understand that question because they're rotating. This is what we talked about before. If I rotate this region around the y-axis, what's going to happen?
It's gonna overlap.
It's going to rotate through itself. Yes, I don't know if they did that on purpose or not, because it's a weird situation when that happens.
So what would you do?
Well, I mean, if you try to force it, so now we know it's going to be integral dy, because
dy.
I'm going around the y-axis. Everything then's got to be in terms of y, which really is gross, because in terms of y, if I try to solve this for x is both positive and negative, I'm going to have two different things. I've got to split my integral across two.
Yeah.
You guys got it with me?
Yes.
All right. Because if I go from here, let me see how to say this. From here out, this is exceptionally, I don't think they meant that. Yeah, I can't imagine that they meant that. That's just weird. We're not going to do that. Yeah.
Can we do 3F?
I got to see what they did. I'm curious, because I don't think they meant
You
that.
just rotate from the positive side all the way around. So it has that symmetry.
It just doesn't make much sense. I mean, here's my radius.
Yeah.
But when you rotate this, it's not something you do if it's going to rotate through itself, because that physically doesn't make sense.
How's it going to rotate itself?
Because if I rotate it around the y-axis,
Can we break it in the middle?
you have to. You have to break it up because
It's going to be like a weird
let's see.
Well, can't you just do the right side?
Are you saying it's going to rotate through?
right here you have to break it up because it goes. The radius is from this to the circle, and then right here it changes over to the parabola. So you got to break the interval up there. The negative positive thing doesn't come into play because the radius is symmetric around there, so the negative part doesn't matter. But it's just, I think they meant, that they should have done it around like x equals to 1 or something. That would make more sense. You never see a shape revolving through itself because you just don't do that. Because it'll actually bore itself out. Sometimes it'll come out to 0 because it just kind of cancels itself out. Doesn't make any sense. So we're not going to do it.
Skip 34.
34B.
34.
34A is completely doable. We did it.
So can you do 3F.
3F. This here. So I'm going to train you guys, or in the little bit of time I have left, to not worry about coefficients at all. Maybe some of you guys already do. Anything x squared's derivative is something x. So I know I've got the derivative of this inside function in there. It's beautiful. So it's perfectly set up for u sub. Any constants I'm missing, I can give it really easy.
Just checking out, like that 2x had not been there. That was the impossible one, right?
Yes. Not impossible, just not currently possible. So what would you let u equal? 3x squared. So du is... So I'm missing a 3. I like it. So 1/3, 3. Okay, so this 6x dx, that is
E to the U.
6x dx is du. So that all gets replaced there. And then e to the 3x squared is e to the u. And then here you go. Thank God, or thank whatever your deity of the day is. 1/3 integral e to u is
E to U.
e, and u was. Is that cool?
Yes.
Yeah. Not too bad.
It looks so clean.
And this is the kind of problem I would have given you back in 4.8. Because if you think about it, you take the derivative, the 6x would come down, you're missing a 1/3, so it must be, if you think it's e to the 3x squared, you're off by 1/3, but you're supposed to only have 2 there, not 6. So you put the 1/3 there. I don't know if you guys see what I'm saying.
Yeah.
U sub makes that kind of work itself out. Whereas you could certainly kind of reason it out with a lot of these functions. What constant has to be there to make it work. Yeah.
And also 15 section 6.1.
15?
6.1.
All right, so 15 is from the areas between curves section. That's a good one. All right. Y equals e to the x. Y equals x e to the x. And you want to find the area enclosed by these curves. What am I missing? X equals 0. So x equals 0 is also known as the y-axis. I love it. So it's the y-axis, e to the x. And here's e to the x. Whoa.
What section is this? 6.
Oh yeah, 6.1. And then x e to the x is a nifty one. At 0, it's going to be 0. I love it. At 1, this is, of course, this one is e. At 1, this one's going to be same. So that's where they meet, at 0 and there. So this one has a little bit steeper slope because of the x value there. Eventually it has a steeper slope. How are we doing so far? Is it cool? I'll take that as a yes. Okay. So that's the region we're talking. We want to find the area between those two. Section 6.1. Once you've seen sum of 6.2, and if you're able to kind of set sum of 6.2 up, 6.1 is instantly so easy. So you're not rotating anything. It's just find the area between those two. So all you care about is which function is
x minus.
Yeah, which function is on top? Which one are you going to subtract from you? So the top one is e to the x, and the bottom one is the other one. And I'm going from 0 to 1. Now, you know, the other way to figure out where these meet is to set them equal to each other. In general, you don't divide by anything that has a variable in it, but because e to the x never equals 0, I can certainly divide by it, so I get 1 equals x, a, and so if you divide by it, that's great, but you're also losing the 0 part, right? 0 is kind of weird. Why do they? Oh yeah, it's not where they meet. It's just because of this guy. I always forget it. So 1 equals x, so it goes from 0 up to 1. That's where they meet. And that's not going to be... Now this is going to be a little bit freaky if you don't notice something. Because there's no way we can currently do this. I don't know if do you guys realize that? Besides, you just said so. But I can't do this integral. Because I can't let u equal, because it's going to be u. It doesn't really help me out, right? But what's really nice is they both have e to the x. So just doing that one thing makes this whole thing doable. Does it?
So you just rewrote it then in this particular case?
So
you just rewrote it and that's...
Yeah, but does that help me?
Not really.
So how else do they want you to do this? Is this what part of the question is? Find its area.
That'd be awesome.
Yeah, you can't do that one yet.
Can't do it multiply by Ln.
Are the tests going to be like this?
No. Well, no, that won't work.
Because you can't bring in Ln.
No, you can't do that. What they're thinking here. This is crazy.
Just to clarify, the 1 is equal to x there. What would that value represent, just like with regards to the function? Is that the just where they meet?
Yeah.
Well, let me do this. I'm sorry. Say it again.
That value where it says 1 is equal to x. Is that just where the two functions?
That's just
meet?
where they meet. That's another
okay.
way to see where they meet.
Okay.
Yeah. Okay. I'm trying to figure out what they want you to do here, and I can't. Because later you learn a way to do this. In fact, one of the first things you learn in Math 280 is something called integration by parts. And then something like this becomes stupid easy. It's almost like, we won't go there yet. But I'm trying to figure out what they want you to do here with what you know. You can't solve this for x. Do you see that? You can't solve this for x. You can't like turn this region around. That would be trying to take in natural logs. I don't know if that's what you meant when you're saying trying to rewrite this in terms of x equals a function of y. You can't solve this for x. It's going to bug me.
The answer actually is that there is no solution.
Oh, really?
It only intersects at x equals 1.
Gosh, it's almost as...
Bumble.
God. That's why I can't figure out what they want you to do, because you can't do shit with it. All right. And in full disclosure, actually, on 3B, on my practice test, I didn't do this on purpose, to tell you honestly, but you end up not being able to do that first part, e to the radical x, because you don't have the chain rule piece that you need. So that's sort of in the same vein. All right, that makes you feel a little better, but I don't know if you guys are on this. So the official answer to that is, for Math 180, you cannot do that. Math 280, you'll learn something that's going to be 2 minutes, you're done. Right? And if you're not taking 280, that's too bad. That's a cliffhanger. You're just never going to hit the bottom, sorry. Okay. Anything else that we can...
Can we solve 3 at the same section?
Which one?
3.
Number 3?
Yeah.
Okay. All right. 3 looks promising. Let's see. God, that's really evil. Just can't get over that. 3. All right, so they pretty much set this up for us. We've got x equals y squared minus 2. X equals e to the y. Y equals 1. Y equals negative 1. That's some really weird shit here.
We can't do the use substitution.
So this is going to be integral d what?
dy.
You see how everything's kind of like turned around from what you're used to?
Right.
So, and actually this way,
What
really.
is it?
Which function is going to be up top?
dy.
Yeah, so I'm going to do integral e to the y minus,
Y
Is
squared.
that y squared minus 2?
good, and you got to subtract the whole function. We talked about that minus, how evil it can be at all levels of math. Minus the whole function, that's going to become a plus 2. And your limits, it's in terms of y, so your limits are given to you, which is nice. There's no figuring out when they meet. They give you the limit. They give you the interval from -1 to 1. Right, so that's not too bad. Is that cool? That's the part that I think should be the hardest part about this section, is just getting used to seeing areas and intervals and things in terms of y instead of x. We're just so programmed to think x is controlling everything. Well, y could certainly control some stuff, right? It's completely arbitrary that we set it up that way. Okay, and if you're going to Calc 3 someday, take that to 3 dimensions and then have fun. That's Calc 3. Figuring things out in 3 dimensions. And integrating. Yes. This is not a hard interval, right? You guys, is that cool?
Right. No.
When was Calc 3 developed for you guys?
When was it developed?
Yeah. Was
I
it
mean,
developed like way past Newton and Leibniz?
a lot of what we learned wasn't invented in the order in which you learn it. Trust me.
It's wrong.
So very often now we're at the point where we're like, okay, now it makes more sense to talk about this first because that sort of leads into this because they figured that out in some weird ass way that we don't use anymore. So that's how we set up how we teach it. But it isn't always how it was invented, right? So even though I barely referenced I meant to do it a lot more often, but I barely referenced my own little timeline. I want to integrate that a lot more into classes. I want to, math people very rarely, as a math degree, do you get any real exposure to the real math history. And all the different contributions from all these people that people never hear about. Thankfully Cosmos is bringing some of them in, talking about them, but
At the university level, are there any like math history classes?
there are, in fact,
I know somebody is getting to learn how to do like Mayan math right now.
yes, I teach that in my 120 class. I teach Mayan numerals. I don't get into arithmetic really. I teach Egyptian hieroglyphics, but we don't really get into like.
Yeah, that's what they're doing hieroglyphics too.
I do. It's cool. But I'd love to. Yeah, there's a. Very often it's a math class. The way I had it, it was a math class. It was a proof class in the first half, and then it was kind of like a history where we had to do some essays and stuff on various people throughout history and what they contributed in the second half. So very often it's like a twofer. But nowadays I've seen a lot more math history courses. Yeah. Anyway, someday I might take a sabbatical and travel the world, saying that I'm going to create a math history cultural class just so I can travel.
So what problem? Oh, sorry.
Looking at this, the e to the y is the top function. Since when you evaluate it, it takes the area above the axis you're working with. Is subtracting the same as subtracting a negative area? Is that why it works?
Yes.
Okay.
Why is
Because these values are negative all throughout here.
Right.
They will end up adding on.
Okay. So it should have been 2, but that makes sense. Or just
Why is e to the y the top? Oh, because it's
Yeah.
And what's really funny is, can you imagine? I could take I could take that out and put it there, and of course that doesn't affect the area at all.
Yeah.
But then it's a little more like what you're used to. Now it is that minus that, but just because I put that there,
Right.
the area is the same, but it's going to work out. So this one would be I got to be careful now because that would be well, the area within here would still be this minus the area here, which would be there, right? So now I just put the axis in the middle, and it just makes it. This is now negative, so minus actually adds it in, just like you said. It's perfect. Cool.
Now, do we take the antiderivatives of
Yeah. So now to finish this out,
that, or we let you?
you don't need to let u equal anything there, right? So it's you have to be able to tell when you need to use sub and when you don't.
I know.
So you know on the test, I'm just going to give you a big, integrate these. Use U sub when necessary. I'm not going to say use U sub on part B and F and W. All right? Good Lord, there'll be a long ass section. But this, I mean, just e to the y minus
1/3,
Why
1
you? Yeah.
plus. You guys all right?
Yeah, 2y.
2y.
So we did add another variable in here.
And y, so
And you just plug in 1 and negative 1.
We can automate. Just have this other variable in there.
Not too bad, right?
I like it.
Better. So, and real quick on that, obviously from your quiz, some of you guys can see when I give you trigonometric functions with angle inputs that you know the value of, I don't want a decimal answer. I want the exact answer. Right? So just reach for that calculator automatically. Yeah. Oh, yeah.
Do we need number 18 in the same section?
the question was, what problem is that one that we just did?
Oh, this was
3.
3. Yeah, 3.
And
So 18.
that one's 15.
18, so let's see. Hopefully this is doable. So they want to find the area enclosed by these functions. So let's see, y equals square root of x minus 1. What's its domain? Where does it start at? Or think about how has it been shifted?
Has to start at 2 or above that.
Has to start at 1. Because that's where 0 is allowed to be 0. Yeah. So at 1, and then it goes from there. So 5 would be 2. So get a little quick. Here's my y equals square root of x minus 1. And then this is y equal to x minus 1. So up 1 over 1. Up 1 over 1. Up 1 over 1. So my line, make a big dot. Okay. That's kind of gruesome. What do they mean here? Let's see. Again with this. Sketch a region enclosed by the given curves.
What they gave you?
Square one side.
All right, so I have to apologize for the book here. I don't know if you guys see my dilemma. I think they're assuming that they mean this area here.
Okay.
Because that's where this domain stops, and then you see where they meet here.
Yeah.
That kind of, but it's a little bit much to leave open to interpretation, but they must mean there. I mean, this keeps going, obviously, but there's nothing there.
Correct.
So obviously, throughout the whole thing, what's on top?
Root x minus 1.
Yeah, root x minus 1. And then, and this is definitely, it could be dx, so that'd be minus x minus 1. Thank you. And now all I got to figure out is,
Intersection.
so I know it goes from
0.
0 because the radical doesn't exist. Did I draw that wrong? Did I go through the whole thing? That's why I'm having trouble.